Now we want to look at this last one, which is the second part of projectile motion. But we are going to look at case one, case two rather. We have looked at case one, the first one, which is coming from projected from the ground level and landed at the ground level. Now all those equations I gave you for case one cannot be used for case two, case three, and case four. But I want to give you some vital formulas to solve question on these cases. Now, these cases is what case one is talking about, or case two is talking about a body projected from the ground level with a velocity of projection u at an angle theta and landed on a particular tower height. And landed on a particular tower of height h. Now, in this case, now h naught is equal to 0 meter because it's projected from the ground level and landed at what? At a particular height here. So h final is h final height, which is what? Above the, assuming it landed on the ground, it will not become the case one case scenario that we have. Now, how do we find the range from where it was projected to this point, where the horizontal range, where it landed, or to this point where it landed, the range? Now, for us to find the range, the formula to use is what? Just use your what? R equal to what? U cos theta times what? The time of flight. The time of flight. U cos theta times time of flight. Where U is velocity of projection, theta is angle of projection, then T is the time of flight from here to this point A to what? To B. That is your range formula. Now, how do we get the what? The maximum height. The maximum height. Fortunately, the maximum height from here to this place will still be the same formula I gave to you before, which is what? You go to what? H equal to what? U square sine what? Square theta over what? Over 2G. So the time of flight will still remain this. Why? Because it's thrown from the ground level to attain this height. So the height from the ground level still remain like the first case. Now, time of flight. For you to solve time of flight, you are going to use this formula h1 minus h naught equal to what? U sine theta times t minus half what? Gt squared. Now, these are the formula you are going to use for calculating time of flight. If you arrange this formula by multiplying all 2 by 2 and what? Arrange them, I want to have what? Multiply 2 by 2, then rearrange. What we want to have is that we want to have our formula to be what? Gt squared minus multiply by 2 by 2 and bring it here. I would have 2u sine theta times t. Then plus what? 2 into bracket what? h1 minus h naught is equal to 0. So this one is what I want to use for what? To calculate what? Time of flight for this particular case. Don't forget that from this formula, this is quadratic equation. You can find your what? Your time through what? Quadratic what? Because this is like what? AS, like what? AS squared plus BS plus C is equal to what? 0. So your C is like this one. Your B is minus 2u sine theta. Then your A is what? G. So you can get your what? The time of flight from there. Now, another thing again I want to understand is trajectory equation. Now, what is trajectory equation? There are two parameters that are very, very important to use for solve trajectory equation here. Number one is your range from here to this place, and number two is your height. So for you to solve trajectory equation, don't forget that the h naught here is 0 in this formula. h1 is what? The final height, which is what? This height of which you are going to use here. Then your theta is angle of projection. Don't forget. U is what? Velocity of projection will be given. Then T is the time you are looking for, using that quadratic what? Formula to solve it. Your A is your G. Your B is your minus 2u sine theta. While your C is what? 2 open bracket h1 minus h0. Now, trajectory equation. Now, what you're going to do is to what? Your trajectory equation is what? You're going to use h1 minus h0 equal to what? X tan theta minus what? Gs square over what? Over 2u square cos square theta. This formula I want to use to solve what? Now this s is like your range. This one is your x. Your h1 is your what? This I. Your h0 is 0. So when you use this formula, you can use this formula to get your theta. You can use this formula to get your what? H final. You can use it to solve for what? Initial what? Velocity u initial. Velocity of sorry, not initial velocity, but velocity of projection. Your u can be used to solve this trajectory equation. Can use to solve it. In fact, if you want to, you can convert this equation to become what? It's like quadratic equation. How? Don't forget that 1 over cos square theta is equal to what? Sec square theta. Because there is a 1 up now. 1 over cos square theta equal to sec square theta. So you can turn the equation to become what? H1 minus H0 is equal to x tan theta minus what? GS square over 2u square sec square theta is safety. And this one, since 1 over cos square theta is sec square theta. And don't forget, sec square theta is safety as 1 plus tan square theta. So you can from there, you can turn it to what? Become a quadratic equation. Because I will still talk more about that. Let me go to this number 2, case 2. Case 2 has to do with what? Range. How to find range? Range still remains the same. R equal to what? U cos theta times t, time of flight. So that means you need time of flight to solve for range. You cannot use that u square sine 2 theta over g. Reason being that the body is not thrown from the ground level and landed back at the ground level. So using u square sine 2 theta over g will not work. Is this one that will work? So this one that will work. So now, what about the height, the maximum height? I'm still continuing with number 2 here, following this. The maximum height will be what? The height from here to this place plus this h initial plus this h0. So this is the maximum height from the ground level. H0 plus what? So it now be what? H0 plus h. So that is what? The maximum height that we want to have. H0 plus h. H0 is this one. H is this one. Now, if you cover your eye to look at this part like this, it look like case 1 from ground level to the ground level now. So if you want to use this to calculate this height, you can use this formula. You start calculate it to calculate from here. Let's say assume that this is the ground level. Look at the board. Now, if this one is ground level, from here to this place, you can calculate your h as what? You can now say h0 plus what? U square sine square theta over 2g. So this is your h, small letter h, plus h0 will give us what? H mass. So the h mass is what? From here to the ground level. I want to check my mic to the ground level. So this is the ground level. So that is H max. The initial height of the tower plus what? U what? We check, we did not add initial height of the tower here or final height, right? Because it's starting from the ground and raise it to the maximum height. So from here to this to the ground level is your maximum height, just straightforward. But in this case now, you have to add your H plus what? U squared sine square theta over 2g. Now, what is our time of flight? The same thing. You use the same formula for time of flight for that. Yes, the same formula will still be old in there. So if you want to repeat, you have gt squared minus 2u sine theta plus 2 into like what? H1 minus H0 equal to what? 0. Now, if you check in this case what is your H0? H0 is where it was thrown from, where it was projected from. H1 is 0 here. So what is the difference between case 1 and case 2? In case 2, rather, H1 is what? H final is H1. H1 is H, while H initial is 0. But in this case, the opposite is the case. So I would have what? 0 here. Now, having known that now, The next thing to note is this, is that whenever you are dealing with this one, don't forget I told you H initial, H final is 0 meter, H initial is height. So take note of that, of this. Now you see use your formula and all that. But trajectory equation, when you can use trajectory equation to find theta 1, theta 1 is what? Below the horizontal level. Theta 2 is above the horizontal level. I can use it to find theta, which is simple as what? H1 minus H0 is equal to what? S tan theta minus what? GS square over 2U what square sec square theta. Now don't forget that this one can be written as what? H1 minus H0, as I said before, S tan theta minus GS square over 2U square into by the 1 plus what? Tan square theta. I told you before. So you can write it like that. That means in place of sec square theta now, I can replace with 1 plus what? Tan square theta. You still get your answer. This is GS square over 2U square. GS square over 2U square. Then open bracket 1 plus tan square theta. Because sec square theta is not what? 1 plus tan square theta. Then this thing has turned to what? Equation. S square will now become what? We can write it as what? Look at it. You can write it as, take this one to the other side, become what? If you take this one to the other side, become GS square over 2U square. Open bracket 1 plus what? Tan square theta minus, if this one go there, we would have what? S tan theta. If you cross the equal sign to the other side, plus what? Plus what? H1 minus H0 equal to what? 0. So if you check the equation very well, what the coefficient of x square now is G over 2U square, the 1 plus tan square theta, S square, as all this one as coefficient. What the coefficient of x here is minus tan theta. What is C here? So if you compare them with what? Using AX square plus BS plus C, you can turn it to quadratic equation and solve. You understand? What I did was to take this one to the other side, move this one to the other side, then this one remain here as plus. So that's what I did. Now you can turn it and solve it as quadratic equation. So you can get your two values of S, you can get theta, two values of theta. If it's theta you want to solve, then this one become, you can turn this one to K square. I won't apply it in the next class. Just ensure that you watch that next class to see how I'm going to apply all this. So just take note of the formula. Then the last case is what? The case of, now please, before I go on, if you want to use theta, sometimes you are not looking for S, maybe you are looking for theta. Now your theta can be solved for by what? Sorry, let me write it here. Now what? GS square over 2U square, if you open the bracket, plus what? GS square over 2U square tan square theta minus S tan theta plus what? H1 minus H0 equal to 0. Now if we check, this one now can take this one to the other side, which now becomes what? GS square tan square theta minus S tan theta plus what? GS square over 2U square plus what? H1 minus H0 is equal to what? 0. So this one becomes what? AS square plus BS plus C is equal to 0. So in this case now, what are we saying? That means we are looking for theta now. That means this one will now become your what? S square. This one will now be S. Then this one, everything here is C. Everything here is C. So in this case now, what will now be our A? Your A will now be GS square. Your B will now be what? Minus tan theta. Then your C will be everything here. So that's how you get your what? Your tan theta. Anyone that give you minus sign from the tan theta will be depression. Then anyone that give you plus from the is your elevation. So if you solve your theta using this formula, sometimes you can turn our tan theta to be K. Then this one, when you say tan theta equal to K, that means K square. This one tan square theta will not be K square, so that you can solve, you can see better. So if you solve your theta will have two answers. Number one answer will be what? Positive. The second one will be what? Negative. Except the two of them are elevation. That's why they will give positive. The one that gives positive is what? Angle of elevation. The one that gives negative will fall below the horizontal, which is this angle here. This angle here will fall below the horizontal. That's what we are going to have as answer. Now, we'll apply them. The next one or the last one is what? When a body is thrown horizontally. When a body is thrown horizontally. When a body is thrown horizontally. How do you find what? Let me play this one. Now, if a body is thrown horizontally, what do we have? Now, the body cannot continue to go like that horizontally. It becomes spiritual because gravity is acting on it. Gravity will make it drop and form a parabola. This parabola. So in this case now, when the body lands, Uy equal to what? 0. Uy equal to 0. While Vs is still what? Constant. Is equal to Us at the point of landing. Don't forget. Because why? Uy is what? Does not, Vs and Us are constant, are the same. G, don't forget I told you when I started the motion that G is 0 for this motion. So it does not depend on it. G does not depend on what? On the motion or along the horizontal. So if you want to, for the time from here to this place is what we call time of flight. So if you want to solve, I would have H equal to what? Using the height equal to Uy times T minus or plus, because it's moving towards gravity. Look at it. GT squared. So what's our what? Sorry, let me use T here. This one will cancel because Uy is 0 as the body lands from this bottom of the tower. So what we have our H become what? Half what? GT what? Squared. Let's take on that, the height. What about the what? The range. The range, as opposed to form the range. So this one is height. This 4 here. The range is what? What is the range? The range is what? Because the body is thrown horizontally, theta is what? 0. So cos theta is 1. So cos will have what? Ux times what? Time of flight. Times time of flight. So now the next thing to do is what? This range now. You can solve for time of flight from this first formula. I'm making time the subject of formula. Multiply all through by 2 and divide by G. I would have 2H over G and square root of everything. That's if you make time of flight the subject of. What is time of flight? The time from here to this point. Time from rest to rest is time of flight. This is equation 1, equation 2. Don't forget you can put your time of flight and substitute it in range here. You can put this one here as substitute. This is equation 3. Now the next thing is what? How do you calculate the vertical what? Velocity. Vertical velocity is changing with gravity. So gravity is constant. So not what? Uy squared, Vy squared plus what? 2G what? H. Therefore, what is our Uy? 0. So Vy is equal to what? Square root of what? 2G what? H. So how do you get your US? Either US or VS. You can get it from this equation. So VS or US is equal to what? So you divide both sides by time of flight, that would have range over what? T. That is your what? Your US or VS, which is constant. Constant. Now, what is our velocity of impact? The velocity at which it touched the ground. It was the velocity of impact for all the cases, case 1, case 2 that I'm doing now, case 3, case 4, is equal to, I did not give you 6, please take note of that, is equal to what? Vx squared plus Vy squared. So know your vertical what? And horizontal velocity. Once you know your vertical, let me check the mic, and the horizontal velocity, it becomes clear. Your vertical is your Vx, Vy, your horizontal is your Vs. So even in this case now, know your vertical. I told you how to find your vertical. The vertical, you can solve your vertical for this by using what? Vy equal to u sine theta minus gt. Please take of that. Your vertical can be solved. Now, what is time? The time take from here to this point is what we call t here. Then u is what velocity of projection. Theta is what? Angle of what? Projection. So if you get your angle of projection, you can get your vertical velocity, this vy. To get your vx is equal to what? U what? Cos theta. That one is constant. So once you get your vy vs, you can what? Get your what? Final velocity. So final velocity is what? Gotten by what? Vs square plus vy square root of everything, you get it. The same formula here. If you don't want to use this one, you can use the other formula, which is what? There is another formula for vy, which is vy square equal to uy square minus 2gh. You can still use that one. But this one is respect to time. It gives you the what? The time from this point of projection to B. So this vy, this is your vs, which is what? Along the horizontal is constant. Just like the velocity along the horizontal is constant, the vs equal to us, which is equal to range over time of light. So time of light is gotten by using this formula. So to get vy, now vy in this case, now to get your final what, you can use this formula now. Vs is what? What is our vs? We know it, we will give yours. What's our vy square? Don't forget vy square is equal to what? 2gh. So this one will give us velocity of impact on the ground, or velocity of touching the ground, or the final velocity on the ground. While your range from the range is measured from the bottom of the tower to where the body hits the ground. So from the bottom of the tower to where the body hits the ground is what we call your range, and it's got to what? US times what? Time of light. So I believe that question, our next class, I'm going to trick question to what? To properly clear the doubt of some students concerning this topic, so that you can understand it. Ensure you watch out for the question part of this one. Don't forget that your final velocity changes with time, but horizontal velocity does not change. You can use this one. You can still use the other formula, which is what? That other formula is, we have it as what? Let me place it. Vy square equal to uy square, which is what? Minus 2gh. Then your uy square will now carry what? U sine theta all square. You can use that one to solve your final velocity. Final velocity. You can use this one, you can use this one, depending on the question. So your final velocity just changes with time. So as motion is progressing, it's changing along the vertical motion, but acceleration is constant. But along the horizontal, it is constant motion, constant velocity, but acceleration is zero. Don't forget to take that. So I believe that we have cleared our doubts concerning this topic, and we have talked about part 1 and this part 2. Till when we shall see again, stay safe and enjoy your day. Now please ensure you click the like button and subscribe to encourage me for more. Thank you. God bless you.